Hello everyone, this is R. Vahita, Assistant Professor of MCA Department from Rohini College of Engineering and Technology. I am here to explain a few topics about MC 4102 Object Oriented Software Engineering. We are going to discuss about the topic Hierarchical Object Oriented Design, which is shortly called as HOOD, and Object Modeling Technique in Unit 2. The hierarchical object-oriented design HOOD has been developed for the European Space Agency as a design notation method for the Ada Robinson, which introduced it in the way that the top-down hierarchical decomposition approach is not new. After all, this is a method used with the data flow diagrams starting from a context diagram which shows all the external interfaces with one central process. This process is then decomposed into another process with data flows and control flows interacting between them with consistency checks between the levels. In the same way, the purpose of HOOD is to develop the design as a set of objects which together provide the functionality of the program. The main process is HOOD is the basic design step. Robinson describes it admirably as a basic design step has as its goal the identification of child objects of a given parent object and of their individual relationships to other existing objects, or the refinement of a terminal object to the level of the code. This process is based on the identification of objects by means of object-oriented design techniques. The phases can be summarized as follows. Problem definition. The context of the object to be designed is stated with the goal of organizing and structuring the data from the requirement analysis phase. This is an opportunity to provide a completeness check on the requirements. Then, statement of the problem. The designer states the problem in a correct sentence which provides a clear and precise definition of the problem, the context of the system to be designed, and then analysis and structuring of requirement data. That is, the designer gathers and analyzes all the information relevant to the problem and including the environment of the system to be designed. Development of solution strategy. The outline of solution of the problem stated above is described in terms of objects at the high level of abstraction. Formalization of the strategy. The objects and their associated operations are defined. That is, a HOOD diagram of the proposed design solution is produced, allowing easy visualization of the concepts and further formalization. There are 5 subphases in the formalization of the strategy. That is, object identification, operation identification, grouping objects and operations, graphical description, justification of design decisions. Formalization of the solution is the solution is formalized through formal definition of provided object interfaces, formal description of object and operation control structures, and the notation given to describe the HOOD diagram is the main diagram which is used for describing the structure of the system is a static view of the structure. The symbols used are as follows. It is a class like structure. It is given a class or object name. Then the external operations are done here and the internal data will be given in this. And this is a HOOD diagram for a company, how we are going to draw a HOOD diagram for a company. And now let us see about the object modeling technique. We shortly call it as OMT. It provides 3 sets of concepts which have 3 views of the system. There is a method which leads to the 3 models of the system corresponding to these views. The models are initially defined and refined as the phases of the method progress. The 3 models are object model, dynamic model, functional model. Object model, which describes the static structure of the objects in a system and their relationships. The main concepts are class, attribute, operation, inheritance, association, that is the relationship between the objects, then aggregation. The dynamic model, which describes the aspects of the system that change over time, and this model is used to specify and implement the control aspects of the system. Main concepts are state, sub or superstate, event, action, activity. The functional model, which describes the data value transformations within a system, and the main concepts are process, data store, data flow, control flow, actor. The method is divided into 4 phases, which are stages of the development process: analysis, the building of a model of the real world situation based on a statement of the problem or the user requirements. The deliverables of the analysis stage are problem statement, system design. The problem statement have the object model, which is the object model diagram and the data dictionary. The dynamic model is the state diagrams plus the global event flow diagram. The functional model is data flow diagram plus the constraints. The system design is the partitioning of the target system into subsystems based on a combination of the knowledge of the problem domain and the proposed architecture of the target system. The deliverables of the system design stage are the system design document, which has the basic system architecture and the high level static decisions. The object design, which means the construction of a design based on the analysis model enriched with implementation detail, including the computer domain infrastructure classes. The various stages here are detailed object model, detailed dynamic model, and detailed functional model. The implementation is translation of the design into a particular language or hardware instantiation with particular emphasis on traceability and retaining flexibility and extendability. Thank you.